So what I'd like to show you today is my patent pending invention. And what it is, it's a seismic anchor for curtain wall and window wall for high-rise towers. Now what we're looking at here on this first slide is we see a tower on the right-hand side, and then it has window wall and curtain wall on it. Well, this anchor would be a perfect fit for this type of a structure to anchor the glazing system, the curtain wall, or the window wall to the structure, because it allows for flexibility in the event that the building is moving interstory drift due to a high weather event or a seismic event. So there's basically a couple of different options of how the system can be implemented onto a structure. On the left-hand side, on the lower left-hand side, we're looking at a rail system where the anchors can be mounted anywhere along that rail, along the length of that rail. And on the right of that, we see a block anchor, which would be just an individual anchor that would be located at every module of a curtain wall system. So let me take you to the next slide and we'll talk a bit more about this. So what we're looking at here is a typical curtain wall anchor. Now this type of anchor does not allow for a lot of flexibility if a building was to move. It's a very rigid, brittle connection, so it's not going to allow the movement that the structure would require in the event of a curtain wall. Therefore, it's going to impose the loads and the forces onto the anchor, onto the structure, and onto the curtain wall system. So the new anchor is going to allow for the flexibility of the building. And without it, this is the type of failure events that could occur. These are due to earthquakes and high wind loads. You can see falling glass and debris that has fallen out of the building as the anchor system wasn't flexible to allow the panels to flex and move during the movement of the building. So it's a big public health and safety issue, and it's very costly to the building owners and to the public. Now, what we're looking at here is an example of the seismic anchor, and you can see the different components, and you can see there's a ball stud is basically the main component of it that fits into a frustral cylindrical channel, which mates the ball in there, and it allows for rotation should the building have any move or drift cycles. And here's a comparison showing your fixed anchor on the left-hand side and the new patent pending anchor that shows the ball, and you can see that it allows for rotational movement. The other thing that it allows for, it allows the architects more flexibility in their designs. And really this type of an anchor allows for an architect to shape the building and utilize the same anchor throughout the building. Whereas if you were to use a typical fixed rigid anchor, everywhere you have a change in the angle of the facade, you're going to need a new custom anchor made. So this is just a upside benefit to having the flexible anchor. These are the original rendering drawings when I was visualizing how to make the building anchoring system more flexible during an earthquake. So these are the original concept drawings, and then they're put into 3D modeling just to better illustrate the anchor and its flexibility. Here's a quarter scale mock-up that we built, and on the left-hand side, it's just showing basically the panels or the building at rest. And on the right-hand side, you can see the flexibility in the anchor, and there is no stress put onto the curtain wall system by moving the panels in and out, because the ball anchor takes up the movement by rotating. And some examples of that are a couple more mock-ups that we did here to prove the concept. So these are quarter-inch scale models, and as you can see, the floor can move independent from the floor below, and the anchor allows for the panels to just rotate amongst the ball anchor. Okay, so I'll just stop that and we'll go to the next slide here. This is a full scale mock-up of the components. It's basically the same as the quarter scale, just a full scale mock-up, and it's just illustrating the movement capability of the anchor itself and implementing interstory drift. Now here's an animation that we put together that illustrates the concept. We have a building here that's moving, and as you can see, as the floors move, the anchor rotates, putting undue stress onto the curtain wall system. No undue stress onto it. Now there's several ways that the anchor could be attached to the building. This is showing one of the examples. Preferred method would be a continuous rail system. Now this animation here is showing an anchor that could be adapted to an existing curtain wall system, and here it is being adapted to an existing curtain wall system. However, we're utilizing a continuous rail here, and I believe there's several benefits for the rail. First being structural, and then I believe the other one would be the ease of installation. Whereas the curtain wall would install a lot quicker on a rail system, due to the fact that you don't necessarily have to rely on the accuracy of the placement of embeds. You can see how when the building sways, how the ball can rotate as the floors move, and again, it's minimizing any of the stress that's putting on the building facade, the curtain wall or window wall system. And again, here to illustrate the continuous rail system that runs the length of the floor slab. And finally here, this is an example of a block anchor, which could be implemented into new construction with curtain wall system. Or the other option is the block could be run as a continuous rail. So the marketplace for this has huge potential. I mean, the glazing industry is global. I mean, the modern cities and that more and more are enclosing the exterior of the building with curtain wall systems and window wall systems. And there's over the next 10 years, it's estimated to be $1 trillion industry. And we estimate that the anchor market value could be 1 to 5% or more if sold as a value-added system. Now, why use this anchor? Well, again, it's existing anchor products can be included with this new innovative seismic anchor as a hard specification. It has global field engineering specification cover. It's a new generational product for the global construction and glazing trades. It's very highly innovative, it has flexible design options, and it will create a positive experience for customers, which in turn will create a better future. And benefits to the customers and the stakeholders, it minimizes the effects of weather-related and/or glazing damage. It can reduce injuries and fatalities by allowing the curtain wall system to be more flexible and not rigid or brittle. And this would decrease business losses in the event of a seismic event. And it has greater flexibility in the building facade designs. Competitive advantages, again, it's a new product, so it's generation ahead of existing anchoring systems. And there's a global need for health and safety and better performing products during seismic or wind events. And again, we're allowing more design flexibility options for architects and engineers. Here's some example of our industry experience with curtain walls and window walls. These are systems that were designed by the inventor. So with 40 years experience in the glazing industry, I'm working with some of the largest glass and curtain wall companies in North America. Experience with some overseas construction, custom high-end residential design. So, and this last slide is just again showing some of the images we viewed earlier in the presentation, and then some other 3D drawings and animations of the anchoring system. Thank you very much, and if you would like to learn more about it, here's our contact information. It would be great to hear from you and talk about this further. Thank you again.